In this video, we're going to determine the density of regular objects. And a regular object, again, is something that you can measure with a ruler. You had this little answer sheet. An alarming number of people did not get this correct. You are focusing on the concept of density. Density is a calculated property measured in, and it should be in grams per milliliter. Or you could say grams per centimeter cubed. All right, so all your units must be shown. All your units must be shown, and you're going to use dimensional analysis to do this activity and any activities in lab. We also stress in chemistry the use of significant figures. All right, so when I am measuring this, remember that we have to estimate the final digit. So we know that this lands on the 2.5 centimeters, okay? But we have to estimate, and I'm seeing that it lands right on the 2.5. I don't know if you're seeing exactly what I'm seeing, but it looks to me like it lands right on that 2.5 centimeters. Okay, so I'm going to report that number as 2.5, well, putting it in the wrong place, 2.50 centimeters, because that last digit is estimated. So if, by chance, it happened to be between the 2.5 and the 2.6, then you would say 2.55 centimeters. All right, but remember, we estimate that last digit. Now, a lot of people were measuring at 2.3 centimeters, and I thought, how are they making that mistake? And then it made sense to me how they were doing that incorrectly. You see, if you measure starting at the end of the ruler, not at the line, you're going to measure incorrectly. And that's how a lot of people were getting that 2.3 centimeters. Okay, this is a cube, so the length, the width, and the height are all going to be the same, and I'm reading that to be as 2.50 centimeters. Oops. .50 centimeters. Okay. Now notice that I'm including that last significant figure here, and I'm including the units. You must include the units. This is dimensional analysis is all about units. The identity of my object here, in this case, is copper. Now I'm going to get the mass, and this is where the final answer will have a different number of significant figures depending on which scale you use. So what I'm working with right now is, this is where you can actually read it, is my more expensive scale that measures to the hundredth. Okay, the air conditioner's on, so it's hard to get it right at 0. But I report that answer as 147.18 grams. 147.18 grams. Y'all getting dizzy yet? 147.18 grams. Now let me remind you that let's pretend this number here turned out to be 0. Okay, so I'm just doing a pretend over here. Let's pretend that it ended up being 140.00 on there. Remember that because this particular scale measures with accuracy down here to the hundredth of a gram, you would have to report the number like this with both of those zeros if it gave you that number. Now, one thing that you might be asking yourself is, well, why don't I estimate this digit beyond here like I did with the 0? Well, the equipment is doing it for us. Okay, so in this case, the equipment that we're using, this balance, just pops out a number for us. This one we are manually reading, and so that's why we're estimating this. But even though this is estimated, each of these has 3 significant figures, and I'm going to abbreviate that 3SF. Okay, now calculate the volume in centimeters cubed. Show your work using dimensional analysis. Okay, this is where you have that, bridge between what you're doing with Coach Savage and me. So 2.50 centimeters, and it's always good to go ahead and put that over 1, especially when you're beginning your dimensional analysis. Now, when you do that calculation on your, okay, notice how I included the units on each one. I included the correct amount of significant figures. Now, when I do my calculation here, 2.5, and if you want to put in the 0, that's fine. And I'm going to cube this number, so I'm going to get this number, 15.625. Well, I can write this number down here, 15.625 centimeters cubed. Okay, so now you've got to write centimeters cubed because it's centimeters times centimeters times centimeters. So that's centimeters cubed. Now, but here's the deal. I can keep only 3 significant figures. 1, 2, 3. So this number is going to end up rounding to 15.6 centimeters cubed. The next thing I do is I'm going to determine the density, and I'm going to show my work using dimensional analysis, just like you've been learning. Okay, so I'm going to say density equals my mass per unit volume, which is 147.18 grams, 147.18 grams divided by 15.6 centimeters cubed. So notice that I have put my units into the calculation, which is kind of what dimensional analysis is all about. So again, when I put this in here, this number has 5 significant figures. 1, 2, 3, 4, 5. 5 significant figures here. All right, so 147.18 divided by 15.6 equals, and I get 9.4346 blah 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 grams per centimeter cubed. Okay, now when you're multiplying or dividing, you can only keep the least number of significant figures. This one has 5. 1, 2, 3, 4, 5. This one has 3. 1, 2, 3. So my answer can only be in 3 significant figures. So I'm going to keep 1, 2, 3. So I would report this number as, I'm just going to put it up here, 9.43 grams per centimeter cubed. A lot of people lost points on this very simply because you didn't read, okay? You didn't read and notice you were supposed to put grams per milliliter or grams per centimeter cubed there. So that's a point that you could have had very easily. Okay, all units must be shown. Dimensional analysis. A lot of people are just writing down numbers without units. Again, you may not do that in especially a chemistry level lab. You have to have your units. You have to show your work using dimensional analysis. Now, the significant figures, that's not going to kill you. If you don't report your answers in significant figures, it might be the difference between an A and a B, or a high A and a low A, but it's not going to kill you. So if you just can't handle that concept of significant figures, don't let it stress you out too much. But if you are one of those people that, really wants to get that higher grade, you're going to report your final answers in the correct amount of significant figures. It takes a lot of practice, but it tells me a little bit better. Well, I mean, it does. It tells me how much I can rely on this number.